Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Ukobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so we are on question 2 and still on vectors in 2D, meant to say. Then it says two forces of magnitude 50 Newton and 80 Newton act at a point on a Cartesian plane in the directions shown in the sketch below, right? And then we can see all that the sketch is, we are given a sketch diagram there. Then 2.1 says, give the correct term for the following description. It says a single vector having the same effect as two or more vectors acting together. We know that this term here speaks to the resultant vector. So in all the previous questions, we've been asked to define. Now they defined for us, they just want us to give the correct term. So we know this is the definition for the resultant vector. So you say resultant vector and then you get that 1 mark. Then 2.2 says calculate in 2.2.1 the magnitude of the vertical component of the 50 Newton, right? So we can see that the 50 Newton here is being acted at an angle. So that means we obviously need to find its component. But then here we are just asked for the vertical component. So to calculate the vertical component, just say 2.2.2, that's Fy, and then we're going to have F sine theta, remember vertical component, and then our force is 50 newtons and then sine 30 degrees. Now quickly punching that into your calculator, it gives you 25 newtons. So 2 marks for that. Now, okay, what was that? 2.2.1, sorry for that. So that was in 2.2.1. Then now let's go to 2.2.2. It says the magnitude of the resultant net force, right? Now, you do understand that if we break this one here into components, this becomes Fx, and then up here we have what? We have the Fy. So we only have 3 forces here, which is the horizontal component, the vertical component, and the 80 Newton. So to calculate the resultant net force, we obviously need to first find the net force of the horizontal forces, because we can see that our horizontal forces are going in opposite directions. So the first thing that we need to calculate here is the horizontal component of Fx. We go Fx is equals to F cos theta. Then this is 50 cos 30 degrees, right? Then to calculate that quickly, if we punch in our calculator, we have 43.3 newtons, right? So 43.3 newtons. And then now, to calculate the sum of Fx, or sometimes we say it's the Fx net. So sum of Fx or Fx net, as some of you might know it. We then say this one is going in the positive direction, but this one here is going in the negative direction. Now, what do we know? If two vectors are going in opposite directions, the resultant can be found by subtracting the two vectors, right? So we will have the 80 Newton plus the negative 43.3. So the negative is indicating that it's going in the opposite direction. Hence, we'll have the 80 minus 43.3. So which goes back to the fact that if the vectors are in opposite direction, we have to subtract. Then 80 minus 43.3, that gives us a 36.7 newtons, right? But then to which direction? To the right, because it came out as a positive. Remember, we always take the direction of the bigger vector. So the bigger vector is going to the right. Therefore, this should go to the right. Now let's draw just a diagram indicating what will happen there, right? So if we use the parallelogram method, then we have the 36.7 Newton going there. And then upward, remember this one was going up. So this was upward. And then it will be what? 25 Newton. So note that this is not drawn to scale. Obviously, the 36.7 should be larger than the 25 Newton. But then that's not what we are all about here. Then, okay, to indicate the parallelogram method, we know that we simply put our resultant there. And then all we have to do now is close off this so that it forms a parallelogram, just like that. So not very precise, but then you get the whole idea. Now you do understand that if this is 25 Newton, this also again is 25 Newton. And then if this is 36.7, also here we have 36.7. Now from here we can see that we can extract a right angle triangle, which we can use to find the resultant. So remember, this is the resultant. So if we are using this here, we can find the resultant there by saying, okay, this is f res is equals to fx net square plus fy net square, right? And then now we have what? Our fx net, which is the sum of the fx, we found it to be 36.7. It's going to the right, so it's positive. And then our fy net, the only vertical force that we have is fy. So we have that 25 there. And then we square that. Now, all we have to do is just punch all this into our calculator. Then it gives us a value of, so if you punch all that, it gives you a value of 44.41 newtons, right? So let me just write it here so it's visible for everyone. So F res now, after doing this, it gives us 44.41 newtons. So this was all 2.2.2, right? We were trying to find the magnitude of the resultant force. Note how we did it. We first calculated our Fx, which was this one here, and then we had to find the resultant of the horizontal forces, which we found is 36.7. Now we take the resultant of the horizontal forces and the resultant of the vertical forces. We put them into the Pythagoras theorem because remember, we are using a right angle triangle. So to find our F res here, it's a hypotenuse side. So we might just as well use the Pythagoras theorem and then to find our F res. Then just like that, we have 44.41 newtons, right? Okay, now 2.2.3 is now asking us to get the direction, right? So let me just allow me to erase this part here. So I'm trying to still keep the values. That's why I'm not erasing all of this. Then, okay. Now to get the direction, note that if we are now working with vectors in 2D, you can't say the direction is to the right or up or down, right? Now to indicate your direction here for this one, the direction will be in a form of an angle, right? So your direction comes in the form of an angle. So this is how you get the direction. Every time you solve a 2D question, then you end up using the Pythagoras theorem. Note that to find your direction, you need to use the trig ratio tan theta, right? And then we know this is opposite over adjacent. So your opposite side is your Fy, and then your adjacent side is your Fx, always. So it's tan theta is equals to Fy over Fx. Then this is tan theta is equals to your Fy value, that's 25, and your Fx value, that's 36.7. Now we know we have to leave the theta here, and then inverse the tan. So that's 25 over 36.7. Now you want to immediately just punch all this into your calculator. Then it will give you a value of 55.74 degrees, right? So that's 55.74 degrees. And that becomes your direction. Your direction is in a form of an angle, right? Then that's how you were supposed to tackle this question for a total of 10 marks. It was a very nice question. So, okay, with all that being said, that's the end of the lesson. Please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And also, if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Do not leave them in the dark. Remember, do not be selfish. We are winning as a team.